Alright, now let's talk about the Pre-Cal 12 Trigonometry and Angles unit. So, the first thing we're going to do is sketch each angle in standard position. So to do that, we just kind of draw the grid. And then 110 would be roughly around here with the terminal arm there. Negative 150 would mean that we go, and this is 110, would mean we go the other way, so it would be right here. And this would be negative 150 degrees. If we have to do 400, so then we would basically figure out that if we do 400 minus 360, we would get 40. So therefore, this is basically just a 40-degree angle that is coterminal. So just be like here. And then negative 500 would be basically just saying negative 360 plus negative 140. So one full loop and then negative 140. So that's basically just going to be like right here. And it's going to be like a full like loop around and then here. Okay, because it's over. Same with this one. It's going to be basically a loop around and then here. Okay, now let's put this points on the grid. So negative 3, 4 would be here. And then basically the angle, we can kind of draw it like this. And we can write sine, cosine, and tangent by doing all of that too. But we'll talk about that a little bit later. This one would be negative 7, negative 2. Which would just be 1, 2, 3, 4, 5, 6, 7. And then down 2. So that would be kind of like our angle. Okay, now let's talk about coterminal angles. So angles in standard position, which have like the same terminal arm, are called coterminal angles. So something like 150 degrees would be like this. And then, so this is 150, but it's also 30 degrees if you look at the like reference angle. Negative 210 would be like right here. Or no, negative 210 would be this way, so it would be right here. So these would be in the same spot because this reference angle is also 30 degrees. So 150 and negative 210 would be considered coterminal. Okay, and then 590 would be 360 plus 230. So I'll just draw them both on one grid. So then that's going to be 230. So this is going to be 50 degrees after one rotation, and then 230 and 230. So they would both be in the same location. Okay. So therefore they're coterminal. Now let's talk about the reference angle. So reference angles are the acute angle formed between the terminal arm and the rotation arm, or like the rotation angle and the x-axis. So for example, for 150 and 285, well, 150 would be right here, and the reference angle would be 30 degrees. So it's basically always the acute angle. 285, I'll do it in blue. That one would be right here. And then we know that this one would be 75 because this is 50. Yeah, because this would be 270. So then this angle per here would be 15, and then the reference angle would be the 75 degrees, because it's to the x-axis. 22 degrees would just be like that, 22 degrees. Negative 269 would be this way, and then just up until here. And then this angle here, the reference angle, would be 89 degrees because it's always between 0 and 90, and with the rotation angle and the x-axis. So that's right there. Okay, let's talk about now the radian measure of an angle. So this is a ratio that compares the length of an arc of a circle to the radius of the circle. So you can kind of write this like this, where it's arc length over the radius. And then basically we can say, like, if the arc is the outer, and then we know that circles internal angles all add up to 360, like one complete rotation is 360, the arc length for one complete rotation would be 2 pi r, because the circumference of the circle is 2 pi r. And then basically we can say that 2 pi is equal to 360 degrees as a result. And this is just coming from this arc length over the radius. Right? And we know radius is from the center to any of the outer points. So basically, pi radians is equal to 180 degrees. So then to convert from radian to degree, multiply by 180 over pi. So it would be 180 over pi, like this. And then if we're going from degree to radian, multiply by pi over 180, because they're equivalent to each other. Okay. So let's try these examples. Convert from degrees to radians. So pretty straightforward. Times by pi over 180 would give you 2 pi over 3, because you can divide both of them by 60 and you'll just be with 2 over 3. Negative 315 times by pi over 180. So this is basically going to be 7 and 4. So it's going to be negative 7 pi over 4. 205 times pi over 180. This you just punch into your calculator and you'll get 3.58. Let's go the other way. So if we have pi over 4, and we're trying to convert to degrees, so we'd go pi over 4 times 180 degrees over pi, and then pi's basically cancel, and we'll be left with 45 degrees, because 180 over 4. This one would be 7 pi over 3 times by 180 over pi. Pi's cancel, and you're just left with negative 7, and then 180 can be, and 3 can be simplified to 60 over, or 60 divide on the top and bottom, so it would be 60 here, and then like that. So it just become negative 420 degrees. And then this one would just be 1.57 times 180 over pi, which would just be 89.95. Okay, last thing we're going to talk about is arc length calculations. So remember that arc length is just arc length is equal, or over the radius, gives you angle in radians. So in this one, we can basically say theta is equal to A over R, and we know the diameter is 9.2, so the radius would be half of that, 4.6, and then we know the angle So then we can just go a equals r times theta, just solving for a, and then go a is equal to 4.6 times by convert it to radians, so 150 degrees times by pi over 180, and we'll get 12.0 meters. Okay, try this one. So pendulum question, theta is equal to a over r. So, and then we know that theta be 1.5 times, or no. So we can do theta equal to 45 because we know the arc is 45 over 30, and then we would find 1.5 radians, and then from there we can go 1.5 times 180 over pi and find it in degrees to find that one. So this found us the radians, and then this found us the degrees.